Hello, in this video we'll be going over example 2 from lab lesson 1B. So I've launched Inventor. I'm going to open up a new part file, specifically a part file with units millimeters, so standard millimeters IPT, because the part that we are modeling is dimensioned in millimeters. Just like before, we're going to start off by taking a look at the part that we are modeling. Here we have a dimension multi-view, and we want to identify the main features of our part for modeling one at a time. We can see that this part has a general angled L-shaped profile from the front. It also has a cylindrical protrusion at the top, a rib, and 4 holes. So those are our main features that we'll model one at a time. We also have some rounds at the front and at the top of the part, and those can be modifications we make to our 3D model at the end. So my general strategy is going to start by modeling the L-shaped profile, followed by the cylindrical protrusion, the 4 holes, and then the rib. And finally, we'll add those rounds at the end. So let's get started with a 2D sketch. I'm going to sketch on the XY plane corresponding to the front view. And I'm going to draw out that general L-shaped profile. So I'm going to do so using the line tool. I'll start at the origin to remove some degrees of freedom right from the get-go. And I'm just going to do my best at coming up with the general profile of this L. You'll notice as I go that Inventor automatically applies some geometric constraints. Here we have the symbol indicating the horizontal constraint, which is automatically applied when I create this line. For the next one, now we have the perpendicular constraint, indicating that this line is perpendicular to the previous one. And when I close off this L, we end up with a coincident constraint, saying that this line is going to snap to the origin at this point. So there we go. We have our L-shaped profile. I can right-click and select OK. And now we have 5 dimensions needed to fully constrain this part. So next I'll take the dimension tool, and I'll first dimension the base width of this part, which is supposed to be 130 millimeters. I'm going to zoom out a bit. We know that the angle between these two lines is supposed to be 65 degrees. And we know that the length of this top portion of our L is supposed to be 230 millimeters. So that will extend things quite a bit. Now you'll notice that my part is no longer looking quite like an L because this line still isn't fully dimensioned and it's moved up with everything, but that's okay. If I want, I could deselect the dimension tool, either by pressing escape or right-clicking and pressing OK. And now I can go ahead and drag this line back down to get something that looks more reasonable. Or I could have just left it. I could have reselected the dimension tool, and I could have just dimensioned this to be the 25 millimeters that it is set to be. I'm going to do the same thing for the top. From the drawing, we can see that this is supposed to be 25 millimeters. And there we go. We have our fully constrained L-shaped profile. So now I'm going to finish this sketch. I'm going to use the home button to resize everything to fit in our drawing area nicely. And I'm going to select the extrude tool to extrude this profile 100 millimeters according to our drawing. So I could extrude it in the default positive Z direction, but I'm actually going to pick this symmetric option to extrude 50 millimeters in both directions about our profile. And the reason I'm doing this will become clear in a minute. I'm going to click OK for now, and the next thing we can do is sketch our cylindrical feature that goes at the top of our part. So I'm going to start a 2D sketch. I'm going to place it on this plane of our part. And the next step is just to sketch out the circle that we want to eventually extrude. So this circle has a diameter of 64 millimeters. And next we want to dimension the location of the center point, which we can see from the drawings is 50 millimeters from the top. That's in the front view of our multi-view. And we can see that it's also 50 millimeters from the side edge. So now our circle is fully constrained. We can finish our sketch. And we can extrude that profile as well. So it automatically selects this profile for extrusion, and I just have to specify that we want it to be a distance of 40 millimeters. There we go. So now we have 2 out of our 4 main features. Next, we'll tackle the holes on the bottom of this part. So again, I'm going to start a 2D sketch. Essentially, we want to identify the locations of these 4 holes, which I could do using the point tool. So I could draw out 4 points here, and then I could dimension their locations accordingly. But I'm not going to take this strategy. I'm going to try something different. Instead, I'm going to use the rectangle tool, and I'm going to draw a rectangle. And the 4 corners are going to represent the locations of my holes. Now, we don't really want a closed profile for any other purpose other than the corners representing the locations of the holes. So I'm going to highlight this profile here. I'm going to right click, and I'm going to change this to construction lines. So this won't be a closed 2D profile once we're finished sketching, but the corner points will be here for us to indicate where our holes are supposed to be located. I can still dimension this rectangle. Based on the location of the holes, we can see that the distance from this edge to the top of our rectangle should be 20 millimeters, and from the same edge to the bottom of our rectangle should be 80 millimeters. Finally, we can see center lines going through all of our holes, and this indicates symmetry. So this essentially tells us that the distance between all 4 holes is the same. We know that the length of this line is 60, so the length of this line of our rectangle must also be 60. I could dimension that using the dimension tool. I could also use the geometric constraint equal, and I'm going to do that. So I'm going to set this equal to this one. Finally, we need one more constraint for our rectangle, and that's going to be the distance of this side of our rectangle to the front of our part. And from our sketch, we can see that this is supposed to be 25 millimeters. So now this rectangle is fully constrained. We can see in the bottom right here that this is the case, so we can finish our sketch. And now we can add in our holes using the hole tool. So with the hole tool, I'm going to zoom in here. The first thing we have to do is select the positions of our holes. And again, those are just going to be the corners of our rectangle. So now we have our 4 holes. We have the simple hole selected, so there's no threading or anything, which is what we want. The seat is just none. That means that there's no counter bore or countersink, which is good. We just want a constant diameter hole. The termination is set to through all, which is also good. We want our hole to go all the way to the bottom of the part. The direction is good, and the diameter just happens to be 15 millimeters here, which matches up with the desired diameter from our drawing. So now we can press OK, and we have our 4 holes. So we have the L-shaped profile, the cylindrical feature at the top, and our 4 holes. Next we want to add in the rib. So for the rib, I'm going to go to the origin folder. I'm going to right click on XY plane and make it visible. Now remember that when I first extruded the L-shaped profile, I made it symmetric about our 2D profile. And that's so that this XY plane remains in the middle of our part. This makes things handy when it comes to making the rib, because now I can start a 2D sketch directly on this plane without having to make a new plane offset from, say, the front face of our part. So now I've started a 2D sketch. What I want to do to make a rib is I want to draw a line indicating the furthest extent of our rib, and then I'll use that in the 3D model tab to generate our rib feature. So I want this line that I'm drawing to go from the very front edge of our part to somewhere on this back surface here. To make sure that our line snaps to this geometry, I'm going to use the project geometry feature. So if I use a project geometry feature and I just select the back surface of our part, you'll see a little yellow line appears. This represents the geometry of this part projected onto our current plane. I'll do the same thing for this front edge of our part, and you'll see a little point is projected onto our plane for that as well. So now I can use the line tool, and I can create a line from this point to somewhere on the back of our part. And now this line is automatically snapped to both of these geometries. The last thing I have to do is dimension the length of this line. So I'll just click this line twice and set the dimension of 166 millimeters as the length of our line. And now this sketch, which is just a simple line, is fully constrained. So I can click Finish Sketch. And now I can go ahead. I can use the Rib tool in the 3D Model Create tab. And what I'm going to do is I'm going to select this line as my profile. I'm going to change the option to parallel to sketch plane. I'm also going to change the direction of my rib to direction number 2. And you'll see this generates a rib feature for us. So sometimes you just have to test out the different directions to make it work for you depending on your sketch geometry. Now I have to change the thickness of our rib to a thickness of 20 millimeters, which we can calculate based on the dimensions of the 40 millimeters and 60 millimeters, defining the edges of our rib from the top view of the multi-view. So I'll set this to 20 and click OK. And there we have it. We have our rib. I can toggle off the visibility of this work plane, and now we have all the main features of our part. The last thing we have to do is add in the rounds. So I'm going to select the Fillet tool, and we can see from the multi-view that these two front edges have rounds of 20 millimeters as the radius. So we'll add that in and click Apply. The nice thing is we can apply rounds to multiple edges at once, like we just did. And we also have to apply rounds to the top of our part. In this case, we can see that the rounds have to have a radius of 50 millimeters. And that will give us a semicircular top that's concentric with this cylindrical feature. So we click Apply, and then we can exit out of our Fillet tool. And there we have it. We have our finished part with all of the features.